So students, last time in the first lecture of waves, I had told you about what basically the waves are. What are the characteristics of waves, and what do we call wave? तो प्रोग्रेसिव वेव में वेव के थ्रू, वेव का मतलब था कि वेव में क्या था कि the energy and momentum was transmitted from one place to another place in the medium. We were talking about the material waves. Material waves जिसमें कि हमें we require the medium for the propagation, जैसे sound wave है, water ripples है, ठीक है ना, इनके लिए क्या है, we need the medium, और medium में जब wave transfer होगी so उसके through energy and momentum is transferred. So I had told you कि a certain kind of disturbance means technically a pattern of oscillation. It is transferred from one point in the medium to the other point of the medium, or one place to another place, and that is called what wave. अब मैं wave की phenomenons में आता हूँ, ठीक ना. Wave phenomenon में पहला है superposition, and superposition of waves is the most general phenomenon of waves. Superposition of waves means what? When two waves meet at a point, like one wave is traveling from this direction, it comes to this point, at the same time the wave is coming from, another wave is coming from this direction, it also reaches at the same time. If at the same point the two waves reaches from the different directions, they meet, what will happen after the meeting? Whether one wave will be generated, the resultant wave will be generated and that will go alone, or this wave will keep traveling along its own direction, this wave will keep traveling along its own direction, what will happen? I tell you that. And before that, it's not that only when the waves are coming from the two different directions, then they meet. Maybe one wave is coming along this direction, and at the same time another wave is also coming along the same direction in the same medium. They meet at a point. So now see, what you have to know about it is that when two waves coming from the different directions, they meet at a point, the effect of meeting is only at the point where they meet. After that, this wave will travel with its original characteristics in the direction in which it was traveling, and this wave will keep traveling along its own direction, along its original direction with its original characteristics. There will be no change in them. So the effect of meeting will be only at a point. And if the waves are traveling in the same direction in the same medium, then they meet, then a new wave will be formed. So though you do not know what is the equation of a wave, but see, I described the equation, though you do not know how the equation has come. At this level you need not to know that. If there is a x direction and wave is traveling along the x direction, wave is traveling along the positive x direction. Wave is traveling along the positive x direction, and particles of the medium are oscillating along y direction, it's a transverse wave. Then the equation will be y equals to a sine 2 pi t upon t minus x over lambda. Let me tell you the terms here. Capital T is the period of oscillation of the particle of the medium, lambda is the wavelength, A is the amplitude of oscillation. This is the equation. This is called the equation of a progressive wave. And remember, in दोनों terms बीच में, here we have minus sign, then the wave is traveling along positive x. And when here we have positive sign, the wave is traveling along the negative x. जब यहाँ पे negative होगा, so wave is traveling along the positive x. जब यहाँ positive होगा, तो wave is traveling along the negative x. तो ये इसका equation हुआ. चलो, so first what I'm telling you, if two waves are traveling along the same direction, and then they meet, equation of one of the wave is y1 equals to a1 This equation can also be written in a more simple form. It is A sine omega t minus kx. Abhi in this class, you need not to know what is the much about this, what is k and all. There is another form. Just you need to know there is a form. So now see, one equation is y1 equals to a1 sine of omega t minus kx. The equation of the other wave is y2 equals to a2 sine of omega t minus kx plus phi. Here omega t minus kx, here omega t minus kx. Omega is indicative of what? Angular frequency or time period. Omega equals to 2 pi over capital T. Capital T is what? It is the time period of oscillation. Is that clear? So this becomes, it is called angular frequency. So both have got the same angular frequency. This is called angular frequency. Both have got same angular frequency. They are in the same medium. It is revealed that k is same. Is that clear? And the term inside the sine is called phase. This is overall phase. So there is a phase difference of phi. What is the meaning of phase? Meaning of phase is that, like in one wave, when one particle is at the extreme position, like this, oscillating like this, say, or it's oscillating like this. In one wave, the one particle, when it is at extreme position, in the other wave, the particle at the same position is at the mean position. So there is a phase difference. When we say that the phase difference is not there, in both the waves want to send the same particle at the extreme position together. Both the waves want that particle should be at the mean position together. Both the waves want that the particle at the other extreme should be together. Then we say that both the waves are in the same phase. Otherwise, there is a difference of phase. We call that phase difference is phi. Now, you need not to much bother about this. You have to watch only this. Their amplitudes are different. Their directions are same, positive. There is a phase difference of phi. So there are only two differences, amplitude and the phase difference phi. Now the resultant equation of the wave, the resultant wave that will be made, that will be square root of a1 square plus a2 square plus twice of a1 a2 cos phi. So into sine of omega t minus kx plus alpha. Here you need not to know what is the value of alpha. Abhi zarurat nahi hai janne ki. So what you should know, the question that can come is what becomes the amplitude of the resultant wave. You need to know what becomes the amplitude of the resultant wave. This thing you should know. And one more fact you should know, that the resulting wave is also traveling in the same direction with the same characteristics, क्योंकि यहाँ पे भी k same है, जैसे इनका k था, omega is also same. So the frequency, the characteristics, they remain same. There's only difference in what? A little difference in phase, which has become alpha. Alpha is also defined. Alpha की एक value होती है, but I need not to tell you right now. And amplitude also changes. Amplitude becomes this square root of a1 square plus a2 square plus twice of a1 a2 into cos of phi, where phi is the phase difference between the two original waves. So this is how superposition takes place. And if the two waves were traveling in the different directions, then you will write what? Then the information is what? I'm not writing it here, but you should remember that what? If two waves are traveling along the two different directions, the effect of meeting of the waves, will be only at the point where they are meeting. After that, both the waves will pass along their original directions with their original characteristics. When you see the form of one wave after it has passed the point of meeting, when you see the form of the one wave or the other wave, there will be no trace of this fact present in any of the wave that it has ever met any other wave. Is that clear? So this is a superposition. Now see, a phenomenon related to the superposition is what? It is a beats. This is what beats. This is related to superposition. What is special about beat? When two waves of almost same frequency, not exactly the same frequency, almost same frequency. And we talk about the beats only in the sound waves. It's only for sound waves. When two waves of almost same frequency meet, the resulting sound appears to increase and decrease number of times in a second. When two waves of almost same frequency meet at a point, what happens? It appears that intensity of sound is increasing number of times in a second. Increase, decrease, increase, decrease. That happens number of times. The phenomenon is called beats. This is called beats. Increasing and decreasing of intensity of sound is called what? Beats. And the number of times it happens is called beat frequency. Number of times in a second. And the number of times it increases or decreases in a second is called, this is called beat frequency. This is called what? Beat frequency. So this is called beat frequency. Now you see, जो beat frequency है, it will be in this way. If frequency of one wave is nu1 and that of other wave is nu2, frequency of one wave is nu1 and that of other wave is what? Nu2, then the number of beats per second, मतलब how many times sound will increase and decrease in a second, will be equal to nu1 minus nu2. That will be equal to what? Nu1 minus nu2. This is the number of beats per second. It is this. So if they ask you how the question is given, there is a tuning fork of frequency 512 Hertz. There is a tuning fork of frequency what? 512 Hertz. There is another tuning fork of frequency 506 Hertz. The beat frequency is not very close to each other, so frequency is very close to the number of beats per second will be equal to what? 512 minus 506, that is what? 6 beats per second. So that means what? The 6 times intensity of sound will decrease and 6 times intensity of sound will increase in 1 second. And you have to remember one more thing about the tuning fork, that frequency of a tuning fork, this is called length of the prong. There is the length of the prong of the tuning fork, and frequency of the tuning fork is inversely proportional to the length of the prong. So how do we control the frequency of a tuning fork? If we deposit some wax here on the prongs, if we deposit some wax, the prongs becomes lengthier and frequency decreases. Similarly, when we rub the prongs somewhere, the prong length decreases slightly and frequency increases. Even the slight change in the prong length decreases frequency massively. If there's a slight change, like even the deposition of wax, just a single layer of wax, or even when you rub the prongs with some rough surface so that the prong length decreases slightly, frequency increases. It's inversely proportional to the length of the prong. So the question could be like this, see. They say what? They ask you, there is a tuning fork of frequency 512 Hertz. 512 Hertz. This is another tuning fork of unknown frequency. Its frequency nu is not known. It has to be calculated. They say number of beats are 6. 6 beats. Because number of beats are 6, you cannot say that its frequency is 506. It could be 518 also. Difference from this would be what? 6. So it could be 518 or it could be 506. Now the other data is what? When the second is loaded with some wax. When second is loaded with some wax, its frequency, the beats become 9. Find new. ओरिजिनल फ्रीक्वेंसी क्या थी? अब आप ठीक से देखना. In case its frequency had been 518, 512 plus 6, 518. When you load with some wax, its frequency will decrease. And 518 will become closer to the 512. When it gets closer to the 512, the beat frequency will decrease, but the beat frequency is increasing. It means its initial frequency would have been 506. So it was 506. When it is loaded with some wax, its frequency further decreases. When frequency further decreases, the difference increases and it becomes what? 9. So its original frequency new will be called what? 506, not 518. Is that clear? If it had been 518, then it is loaded with some wax, its frequency will decrease, and when the frequency will decrease, it will become closer to this, so the beat frequency should have been decreased, but it's increasing. It means earlier frequency was 506. Upon loading with the wax, it further decreases, difference increases, and it becomes what? 9 beats. But remember one more thing about the beats. You'll remember, you see, if difference of frequency in the two sound sources is in the range of 10, like 6, 7, 8, 9, 10, 12, 13, 14, etc., beats will be audible. The number of times sound increases or decreases, you can experience that. But if the frequency difference is much more compared to 10, if nu1 minus nu2 is much more compared to 10, 10 से बहुत ज़्यादा है, तो क्या होगा? You remember it, this is an important point. Beats will be produced. Beats will be produced, but will not be heard. Beats produce होंगी, मतलब साउंड की इंटेंसिटी इंक्रीज होना, डिक्रीज होना, इंक्रीज डिक्रीज होना होगा, बट ह्यूमन ईयर को सुनाई नहीं देगा. Human ear has got a capacity that if a change happens within a period of 1/10 seconds, it cannot experience it. If the change takes place beyond a period of 1/10 seconds, 1/10 seconds, then only it can be experienced that yes, there is a change of intensity. Do you understand this? If any change of intensity takes place, but the change time is what? Even less than 1/10 seconds. So those changes taking place, but that change will not be observable by the human ear. Means human ear is not that sensitive. इतनी जल्दी change हुआ कि लगेगा जैसे यूनिफॉर्म साउंड है, वो increase or decrease cannot be experienced in that way. But what? But if change is the change increase then decrease, and that is in a period more than 1/10 seconds, then it can be observed. So remember this. They say frequency of one tuning fork is 540 Hertz, and frequency of one tuning fork is 510 Hertz, 510 and 540. Now they ask how many beats will be heard. Your answer will be what? 0, because 30 beats will be produced, but beats will not be heard. So how many, if they ask you how many beats will be produced, you have to say 540 minus 510, that is what? 30. But the question is how many beats will be heard. Your answer will be what? 0, because no beats can be heard. Didn't see. Now see, after the beats you have one more phenomenon of superposition. Is this only when the waves, different type of waves meet, or the waves meet in a different way, there's only that. So one phenomenon of superposition is what called interference. Interference of waves is a wonderful phenomenon in which what happens when the two waves come from the two different sound sources and meet at a point. Suppose here we have one sound source, another sound source here, S2. the waves are being emitted in all directions. They meet here, they meet here, they meet here, they meet here. Waves are meeting at a different points. Now what we find, generally your perception will be what? If I tell you that intensity of sound source, this sound source was I1, the intensity of this sound source is I2. Your perception will be that intensity of sound here should be what? I1 plus I2. Here it should be what? I1 plus I2. Here it should be what? I1 plus I2. But we don't find that. What really happens is, at some points intensity is more than I1 plus I2. And at some point intensity is less than I1 minus I2. This phenomenon is called what? Interference. In which the two waves, even it could be more than two waves also, when two or more than two waves meet, the intensity at some point is more than the sum of the individual intensities, and the intensity at some other point is less than the sum of the individual intensities. This phenomenon is called what? Interference. So this interference is of two types. One is constructive, the other is destructive. Other is what? Destructive interference. Destructive interference. You know, destructive interference and the constructive interference. Destructive. You see, just few minutes back I had told you one term phase difference phi. In fact, constructive is what? When intensity I is more than the sum. दोनों इंडिविजुअल वेव्स हैं, 2, 3, 4 जो भी है, उनके सम से ज़्यादा इंटेंसिटी है किसी पॉइंट पे, हम बोलेंगे इंटरफेरेंस इज व्हाट? कंस्ट्रक्टिव टाइप ऑफ इंटरफेरेंस. Destructive is what? When intensity I at a point is less than the sum of the intensities of the individual waves. अगर इंडिविजुअल वेव्स की इंटेंसिटी से सम कम है तो हम बोलेंगे इट इज व्हाट? डिस्ट्रक्टिव इंटरफेरेंस. Actually now you see, I had told you in my first class, if I didn't, then note down again the formula. Intensity of a wave I is equal to 2 pi square nu square a square b into rho. Rho is the density of the medium, a is the amplitude, v is the velocity of the wave. So basically you remember that intensity is proportional to a square, because we are talking about interference takes place in the waves of same frequency. The waves which are of same frequency, in them interference takes place. So nu is same, they are in the same medium, velocity v and rho will be same. So the only difference will be in what? Amplitude, and one more term, phase might be different. So now you see intensity is proportional to a square. When two waves meet, the resultant amplitude a dash is equal to what? Square root of a1 square plus a2 square plus twice of a1 a2 into cos phi. I told you just few minutes back. Now resultant intensity I will be equal to what? I dash, that will be a dash k. Remaining term will become k. This. They'll become what? K square. So that is what? K a dash square. In this way, because you know the value of cos phi is somewhere what? Positive. Cos phi could be positive. Cos phi could be negative also. When it is negative, this amplitude a dash will be equal to what? It could be a1 plus a2. If it is plus 1, if it is minus 1, this could be what? A1 minus a2. And it could be in between also. So when you find the intensity, it is k square of this a1 square plus a2 square plus twice of a1 a2. So if the two waves had met in an ordinary manner, not the interference, the resultant intensity would have been k a1 square plus k a2 square, but you are getting an extra term plus 2a1 a2. Similarly, here you will get one term deficit minus 2a1 a2. In this one, sum would have been a1 square plus a2 square, but now what? K a1 square plus a2 square minus what? Twice of a1 a2. So this is what? In this case, it tends to be less than the sum of the two. In this case, it will be more than the sum of the two. But interference follows the law of conservation of energy. It follows the law of conservation of energy. What energy of the waves disappears from one point, the same reappears at some other point. Is that this is what? It's interference. There's one more phenomenon of waves. That is what? Formation of stationary waves. Formation of stationary waves. You see, in the formation of stationary waves, what happens? When two identical waves travel in the opposite direction and they superpose. Superpose means they meet. They superpose. If the waves are identical, they are traveling in the opposite direction. When they superpose, a stationary wave is formed. You only need to know, you got to know the phenomenon. Now you just need to know one more thing about it. That is what? What is a stationary wave? Before that, we were talking about progressive wave. What was happening in the progressive wave was when a wave was traveling in the medium. So I told you, energy and momentum was also being transmitted in the medium. Before that, we were talking about progressive wave. When I told you, like I'm speaking, the audio goes up to you. You're sitting, say, 10 meters away from me. Audio pulse goes there. So sound energy is also a kind of energy which is present in the form of oscillation of the particles, kinetic energy of oscillation of the particles, or the potential energy of oscillation of the particles. So that energy was also moving. What happens in a stationary wave? When a stationary wave is formed, so the rate at which energy is transmitted along this direction, at the same rate energy is transmitted in the opposite direction also. So what is the final result? That in the stationary wave, in a stationary wave, there is no transference of energy in the medium from one place to another place. They are called what? Stationary or standing wave. Particles of the medium oscillate, but the energy is not transmitted or transferred from one place to another place. Energy is not transferred, neither in this direction nor in the opposite direction. This is what happens with the stationary wave. Then see, we have one more phenomenon of wave, and that is what? It is the Doppler's effect. Doppler's effect. See, what is the Doppler's effect? Doppler's effect is that when a sound source moves towards the observer, or observer moves towards the sound source or away from the sound source. Listen to this again. When a sound source moves towards the observer or goes away from the observer, or sound source is stationary and observer moves towards the sound source or away from the sound source, the frequency of the sound heard by the observer is not exactly the same as the frequency of the source. There is a change. This change, what is the change, is called what? Doppler's effect. So this happens when either both are moving or only one is moving, but they have but they are moving. Then the frequency heard is not same as the actual frequency of the source. How much is the change? Look at this. Nu-Des is the observed frequency. This is the observed frequency. Observed means frequency that is being heard. Nu-Des is equal to what? Nu-Naught. This is the actual frequency of source. This nu-Naught into V plus minus VO upon V plus minus Vs. I tell you different terms. V is what? V is the velocity of sound in the medium. V is the velocity of sound in the medium. BO is what? BO is the velocity of observer. Velocity of observer. And VS is the velocity of source. This is the velocity of source. Up now, what to take here, plus or minus? You have to do it like this. I tell you the concept, how to take here plus or minus. If observer is moving toward the source, it will be plus. If observer is moving away from the source, it will be minus. I'm not writing it, you should write this thing in your notes. If observer is moving towards the observer source, it is plus. If observer is moving away from the source, it has to be minus. Now see for the source. If source is moving towards the observer, source is moving towards the observer, it will be minus. It will be minus. If source is moving away from the observer, it will be plus. तो उल्टा है, ठीक है ना? ऑब्जर्वर सोर्स की ओर जाएगा तो प्लस लेना है, ऑब्जर्वर सोर्स से दूर जाएगा माइनस, सोर्स ऑब्जर्वर के पास जाएगा माइनस, सोर्स विल go away from the observer, it has to be what? Plus. Is that clear? ठीक है? So it is this. Now see, this is the Doppler's effect. Doppler's effect means what? Ki the frequency by the observer, if it is not same as the actual frequency of the source, that means any of them or both of them must be in motion. Is that clear? You must have felt this thing, like when you are standing by the side of a highway. You're standing by the side of a highway, say somewhere away from the highway, and you're not noticing that which vehicle is going and which vehicle is coming towards you in the road. You can easily find, you'll find the frequency of the vehicle which is approaching towards you will be heard in a different way, and frequency of the vehicle which is going away from you will be heard as a different pitch, will be heard as a different pitch or different frequency. This is the Doppler's effect. Now see, we have, after this we have certain characteristics of sound wave. So in the characteristics of sound wave, one characteristic is quality of sound. You see, quality of sound is also called timbre. It is also called quality or timbre. Basically, this is what quality or timbre is. This denotes what? This denotes the waveform. This denotes what? Waveform. And what is a waveform? It is this, see. Suppose this is sound wave. So see, what is there in a sound wave? Variation of intensity, variation of frequency. This might be intensity, this might be frequency, etc. Means when you speak, your voice is never a pure note. A pure note means what? The voice that consists of a single frequency. You can never speak even when you clap. This also has got, this clapping sound also has got number of frequencies. A pure note is what? A pure note. Pure note can be, this means a sound of single frequency. So this can be generated only by some typical elements. Like for example, tuning fork. If it is of 512 Hz, it will generate the frequency of 512 Hz and no other frequency, and this is what? It's a pure note. But all the other sources, even if you talk about piano, guitars, harmonium, etc., anything, when you speak, all are what? They consist of number of frequencies. None of them is a pure note. They contain number of frequencies. So when we speak, two things happen. As the sentence proceeds, as the song proceeds and all, frequency keeps changing. Along with that, intensity also varies. So the variation of intensity with the variation of frequency, that defines the waveform. And how is the waveform? Upon that depends the quality of sound. Like suppose someone tells you, you are the audience, and someone tells you that I'm going to sing a song. And the person doesn't sing a song, rather he starts speaking a text. You won't like that. So for what was told you, you decided that quality should be in a different way. The frequency of change of frequency along with the intensity should be in a melodic manner. There should be melody, that should be in a melodic manner. There should be melody from it, and that we call music. But it was not that. You said, its quality is not good. There are some other means also. There are some other few things also by which we decide the quality. Like see, when we speak, you must have seen, you must have heard that there are some persons who speak in such a way that their words seem to be mixed. Means there is not proper separation of words. That's a different type of quality of, that's a different type of waveform. And there, in some sounds, there is proper separation of sound waves. That's a different type of waveform. Like see, deliberately also it is manipulated, like when they say the mutual funds are subject to the market risk. They deliberately want to mix the words in such a way that when the effect of one word has not yet been finished, the other words start. The other word starts, so that the first word cannot be heard properly. So these are different kind of waveforms. And in the waveform, like see, we have music, we have noise. So in the music, basically what happens, the variation of intensity and variation of frequency is in a rhythmic manner. Variation of frequency and variation of intensity is in a rhythmic manner, that is a musical sound. And when there is no relation, how it is varying, kabhi bhi kuch bhi. Jaise aap, you don't know how to play harmonium, suppose then you start playing harmonium. How? Koi bhi key press ki, kabhi bhi hawa. When you pump the air, by pumping the air, you control over the intensity. Now what you're doing, you're randomly pressing the keys. When you randomly press the key, you are generating different frequency of sound. And you're randomly pumping the air also. So the intensity is also varying randomly. There is no rhythm, there is no relation between the variation of frequency and the intensity. That is what it's a noise. And when it becomes music, like what? You are pressing the keys in an increasing order. Sa, re, ga, ma, pa, dha. The frequency increases in a rhythm, or frequency decreases in a rhythm. And that is followed by the variation of, when frequency increases, intensity also gradually increases. When the frequency decreases, intensity also gradually decreases, and all. There are various kind of melodic combination in that way generated, and they are all called what? They are called music. So it's a, these are different kind of quality of sounds or the timbre. Now see, then we have one term. One term we have is the reverberation of sound. Reverberation. Basically, when we speak, the word that we have spoken lasts in the atmosphere for some time. How can we say that? Like see, when I speak, my sound is audible here, and it is audible at few meter also. If it is audible at few meter, it always takes for the sound to travel from this place up to that place. It takes some time. Sound reaches from this place to that place up to some time. And when sound travels from here, what happens to the amplitude is that amplitude of the sound keeps decreasing. So maybe after few meters, amplitude of the sound becomes such that it is lesser than the minimum audible sound. Amplitude decreases, intensity becomes lower than the intensity of the minimum audible sound, and even if the wave has reached there, it will not be audible there. So that means what? After speaking, a word of sound remains in the atmosphere for some time, and that time is called what? Reverberation time. This is called what? Reverberation time. The time for which a sound pulse lasts is called reverberation time. Reverberation time. This is called reverberation time. So reverberation time can be increased or decreased acoustically to produce the desired effect. Like see, in the musical concerts, what happen? They deliberately increase the reverberation time of the announcer. It appears like sound गूंज रही है. It keeps on vibrating for some time. That is what increase of reverberation time. The word that is spoken that lasts for more time and it becomes more effective. Is that clear? Like in the movie theaters also, they are acoustically designed in such a way that a sound pulse reaches directly to you. It gets reflected from the wall somewhere. It reaches to you. Then it reaches from somewhere else, and that reaches almost at the same time. Almost at the same time, or at a difference of very, very small difference of time. So it appears that that sound pulse is lasting for what? That lasts for a big time. You must have seen the heroes like Amitabh Bachchan and all when they speak. It appears that their sound is so loud, and the sound is so means loudness does not only mean the intensity. It appears to be really very impressive. Though normally when human being speaks somewhere else, it's not that loud, or it does not appears to be so impressive. What happens there? They increase the reverberation time technically. So for your syllabus purpose, you should know what is the meaning of reverberation time. It is the time for which, up to which a sound pulse lasts in the atmosphere. This is the reverberation time. Then see, we have one thing called loudness. Loudness of sound. So loudness of sound is not intensity, but loudness, its unit of loudness is what? It is decibel. It is decibel. This is a unit of loudness. And measurement of loudness of sound in decibels is done by what? Loudness in decibels. Loudness in decibel equals to 10 log I over I naught. Now I do not know really whether you know the logarithmic function or not. Like you got to know sin x, cos x. Sin is a function, cos is a function. Similarly, if you do not know now, in future you will know it. In future you note loudness in decibel will be what? 10 log I over I naught. Means I naught is the intensity of minimum audible sound, and I is the intensity of that sound whose loudness you have to define. I naught is the loudness of minimum audible sound, and maybe you do not know, but see, log 2 is equal to what? 0.3010. Because see, it's a very important value, so I'm telling you. Suppose intensity of one sound is I and intensity of another sound is 2I. D1 is equal to loudness in decibel 10 log I over I naught, and intensity of other D2 is equal to 10 log I over 2I over I naught. And in the log function we have log of A into B is equal to log of A plus log of B. So what we get here, this can be written as 10 log I over I naught plus 10 log 2. Log 2 is separated. So because log 2 is 0.3010, so this will become equal to what? 3. That means if intensity of sound is 2 times intenser compared to one intensity is 2 times bigger than the other, the difference in their loudness will be what? 3 decibels. There will be difference of what? 3 decibels. Is that clear? Now see. Now we have another term that is called pitch. Pitch is what? Pitch is not frequency. Rather, pitch is a combination of frequency. Like when we say a singer is singing the song at a very high pitch, a singer is singing a song at a low pitch. So that means what? That means this, see. Suppose in a song like O Mere Dil Ke Chain, O starts
do of the G of
frequency.
1 minus x multiplied by x
The
in
chain na comes at a frequency 3000 hertz. Frequency of sound keeps increasing. O Mere Dil Ke Chain, and the na ends at 3000 hertz frequency. One singer starts from 500 hertz to 3000. Other singer may start from 1000, may end at the 4000. We'll say that the other singer is singing at a high pitch. So low pitch and high pitch does not.
Hello and good morning students.
Cases
होंगे. अब definitely हम वो cases
is spoken. We use number of frequencies. If the frequency of the corresponding words are higher, we'll say that the other sound is what? It is of high frequency. So in that way, classically we have, means higher pitch means not a single frequency. Higher pitch means
the definite integration ऐसा है कि fx cos ना interval of कि like जहाँ पर भी हम split integration का split कर रहे हैं उनके बीच में हो, but जो हमें read कर लोगे आंसर फाइंड कर लोगे. अब what do we look for कि one सिंबल में नेगेटिव है is pi cos pi x 4 cos square x minus of 4 times of
mosquitoes buzzing, female voice, chirping of birds, low pitch sound is also called sharp sound. This is male voice, loins roaring,
the definite integration in fourth quadrant, third or fourth quadrant.
Low pitch sound. Is that clear? So shrill, sharp means slow, shrill means high frequency, and these are the examples. So they may ask you in the questions high pitch sound and the low pitch sound. Then we have after the pitch we have one phenomenon that is called the sonic boom.
देखो सी यार ये चीज क्लियर होती है माइनस एक्स स्क्वायर मल्टीप्लाइड नीचे से स्टार्ट करते हैं. जो सबसे लास्ट क्वेश्चन जो पूछा गया है स्क्वायर प्लस सी 10x मल्टीप्लाई 4 टाइम्स ये टर्म आ जाए. प्रोसेस समझाया था इसको ऑफ साइन ऑफ 2x माइनस ऑफ द a. तो जो अब ऑल्टरनेट तो स्टूडेंट्स अब नेक्स्ट चैप्टर में नेक्स्ट क्लास में स्टार्ट करूंगा दैट्स डेफिनेट इंटीग्रेशन. ठीक है.
Supersonic jet will always be the apex of the pole, and behind it there will be conical zone on which the intensity of sound is very high. Intensity of sound is generally so high that if a window pane falls on the surface of that conical zone, it may break. The intensity is so high that on the surface of that conical zone, if a window pane falls, it may break. And this phenomenon is called what? Sonic boom or the supersonic.
The definite integration.
Shock waves. So remember,
I told you that integration can be split into the many parts.
The velocity.
And what was that property? That integration of a to b fx into of the.
It happens only at the supersonic velocities. And you'll also remember one. The number is called Mach number. This Mach number is what? Velocity of sound. Velocity of that source of sound upon velocity of sound. This ratio is called Mach number. So sonic boom will take place when the Mach number is greater than 1, and Doppler's effect is defined when the Mach number is what? Less than 1. This is called Mach number. I'm sorry. Mach number. This is called what? Mach number. No, we don't have T here. We have MACH, Mach number. This is called what? Mach number. So Mach number, if Mach number is greater than 1, then the sonic boom will take place. If Mach number is less than 1, then only the Doppler's effect will be audible. Is that clear? So we have all these parameters like loudness, pitch, and okay. If I need to tell you anything else, maybe I would have told you in my previous class, but again I tell you because that's a very important point. The velocity of sound in the medium increases with the temperature, and velocity of sound in the medium also increases with the humidity. With the increase of humidity also, the velocity of sound increases. With the increase of temperature also, the velocity of sound increases. Okay, it's all right. So now, as in further some classes, I'll discuss few questions and papers also. So